See, the question says two cubes each for each volume of 64 centimeter cube are joined end to end, and we have to find the surface area of the resulting cuboid. So as you can clearly see in the figure that I have made, I have joined two cubes here, and the resulting figure is a cuboid. Now, what is important to observe here that when we join two cube, then let's say if this is the edge of one cube and this is the edge of the other cube is also same. So we can say that the resulting cuboid, the length of this resulting cuboid will be twice of the original length, but its width are going to remain same. Like if I use B for breadth, the width will be N only, and the height, as also you can see, the height of the resulting cuboid is same as the height of the cube. Now we have to find the surface area, and we know that the surface area of a cuboid is 2 times LB plus BH plus HL. So that means we need to find out the length, breadth, and height. Now, for further information, we should know that we have been given the volume of the cube. And what is the formula for calculating the volume of a cube? It is L cube, which is equal to 64. So L cube 64 is what? 4 cubes. So we can now say L is 4 centimeter. L centimeter. So once we get L here, we can plug in the value of L over here to get the length, breadth, and height. So it is 2 times L, that is 8. And the breadth and the height is going to be same, that is L, which is 4. And the height, which is also equal to 4 centimeter. Now check, as I said, we have to find the surface area, and to calculate the surface area, we just need to plug in the value of LBH. Well, the symbols are important here. We are going to use the symbols as per used here. So that is the total surface area in this case is equal to 2 into L. Sorry, that's 2 into L into B plus B into H plus H into L. So this is 2 times product of these two. That is, let's say write it 8 into 4 plus that is B into H, which is equal to 4 into 4, and HL again it is, this is H into L. So that comes out to be 2 times, this is how much? 32. And 4 into 4, that is 16. And again 32. So 32, 32, 64 plus 16 is how much? 80. Yeah, that's 80. So we'll say that 80 into 2, that is 160 centimeter square. So that is the required surface area. Well, surface area, as you know, that this is the whole surface area. In the next question, it says a vessel is in the form of a hollow hemisphere and is mounted by a hollow cylinder. So let's first make the diagram. As for the information, say I took one, as of now it's a sphere. I'm going to make it a hemisphere. So let's say, right, this is hemisphere here. And let's say this be its circular base. All right. Now this is a hemisphere and it is mounted by a cylinder. So I'll make a cylinder now over it. That's a cylinder placed over it. This is the base of the cylinder. Right. Now, further, when we read it, what do we have? It says the diameter of the hemisphere is 14 centimeter. That means we can say the radius here is going to be 7 centimeter. And the total height of the vessel, that means we know this height from here to here. We know the height, right? And this is given how much? It is 14 centimeter. This is the total height. And Is 14? Is 13, not 14. It is 13 centimeter is the total height. So we have to find the inner surface area. But before that, one more information that we consider, that this is what the height of this is the height of what? The hemispherical portion. As you know, that height is same as radius in case of hemisphere. So this is 7 centimeter. So therefore, what we can conclude, that we can say the height of this cylindrical portion, right, will be how much? It should be 13 minus 7, right? From here to here, it is 13, and this is 7. So their difference will come as 13 minus 7, right? So this is height of the cylinder. That is, h is equal to cylindrical portion is 13 minus 7. That comes out to be 6 centimeter. Right. Once we have obtained all the information, now we can do this question. Right. So what we have to find the total surface area, and what you know that total surface area, in this case, total surface area should be what? It should be the curved surface area, as they are hollow, right? So it should be curved surface area of hemisphere, curved surface area of total hemisphere plus the curved surface area of the cylinder plus CSA of cylinder. Now, what is the curved surface area of hemisphere? The formula for finding the curved surface area of hemisphere, it is 2 pi r square, and the curved surface area of cylinder is 2 pi RH. And see, if I take 2 pi r common, what we are going to get inside? We'll be left with r over here. Since 2 pi r is taken common, it is r plus h. Now, here onwards, we'll be placing the value. But value of pi is 22 upon 7, and the radius, which is 7, plus once again radius, that is 7, plus height, and height of the cylindrical portion is 6 centimeter. So what you can see that here 7 and 7 get cancelled. So what do we get is 44 multiplied by 7 in plus 6 is 13. So we'll say 13 multiplied by 44. So it's 572. 572 centimeter square. It's 572 centimeter square. And that is the required surface area of this vessel. And it's an inner curved surface, inner surface area, right? That's the final answer. The next question says a toy in the form of a cone of radius 3.5 centimeter and is mounted on a hemisphere of the same radius. So let's say if I first make the figure here, I'll first turn them into a hemisphere. Right, that's be fine. Now I'll make the base of this hemisphere. Let's say this is what? The base, and we have to mount a cone over it, right? Yeah. So a cone is mounted. Let's say I join this with this. So this is what the required figure here, and the radius is given. I can take the radius as either 7 by 2 or 3.5. Well, depending upon the calculation involved, I'll be interchanging them. And the total height is mentioned as 5.5. So total height, that means we know the height from here till here as it is how much? 15.5. So this is going to be 15.5. 15.5 centimeter. Yeah, it's centimeter. So this is 15.5 centimeter, the total height. And what we can therefore say from here, that the height of this, that is the height of this conical portion, the vertical height has to be this minus this. Why? Because as I said, that in case of a cone, this is what its height. Sorry, in case of hemisphere, the height is same as its radius. So this is going to be 7.7 by 5 or 3.5. So you can say this height is going to be how much? The height of this cone will be 15.5 minus the radius, which is 3.5. So if I subtract these, I'll get this as 12 centimeter, right? So we can say the height of this height is, this is the height. Now, what we have to find out the total surface area. Let's place this figure aside. Now we have to find the total surface area. Now we'll say that the total surface area, will be what? It should be the curved surface area of the cone and plus the curved surface area of hemisphere, right? It should be of hemisphere. Now, what is the formula for finding the curved surface area of cone? It is pi r L, and the curved surface area of hemisphere is 2 pi r square. Now check here, we don't know the value of L here, but we have a relation between these. This is the slant height. The slant height is this, right? This is the slant height. So the relation is what? L square is equal to R square plus H square. The formula for calculating the slant height, or we may say the relation between the slant height, radius and height. So we can say L square, that is L. This pen is not working. All right, so this is L square is equal to R. R is how much? I can take 7 by 2 plus H, which is given as 12. So it is 12 square. So finally, L square, 7 square is 49 over 4, and 12 square is 144. So L square, if I take LCM, this is 4, this is 49. 144 into 4 is 576. Now, if I do it over here, so we get L square is what? 625 over 4. That means L is what? The under root of this. So which is 25 by 2. Under root of 625 is 25. Now, once we obtain the value of L, we can plug in the value here. Say pi is 22 upon 7. Radius, as I said, I'm going to take 7 by 2 here. And L we just calculated as 25 over 4. But then we can minimize the calculation. I just observed we can take pi r as common. So if I take pi r as common, this is going to be L plus 2 times r. Now replacing pi with 22 upon 7, radius as 7 by 2, slant height we just calculated as 25 over 2 plus 2 times the radius, and radius is 7 by 2. So 2 times the radius, right? We have a radius as 7 by 2. So 2 into r will be 7 only. Now this gets reduced here and we are getting 11 from here. Now I should change the color to understand it better. This is 7 one times and 2 11 times. So we have 11 outside, and if I take LCM on this side, it's going to be what? This is 25 plus 7 into 2, that is 14. So finally it comes out to be 11 multiplied by this is what? 39. This would be 39 by 2. So we can multiply this. Finally, it is 39 into 11, and whatever it comes divided by 2. So we'll get this as 214.5 centimeter square. So the answer for this will be, the final answer for the total surface area will be 214.5 centimeter square. So in this case, you shouldn't plug. In the next question, it says a cubical block of side 7 centimeters is surmounted by a hemisphere. Now, question is, what is the greatest diameter of the hemisphere that can have, and we also have to find the surface area of the solid. So let's say if I first make a cube here, right? It's a cube, and then I'm going to place a hemisphere over it. So let's first I'm cutting this into a should be hemisphere. Now let's I place it. Yeah, that's perfect. Slightly more. All right. This is what I placed it. This is a hemisphere. That's a hemisphere. And this is a cube here. Now, what we have to find out is the greatest, and the diameter of the cube is given as 7 centimeter, right? So this is 7 centimeter from here to here. So clearly we can say that the cubical block, which is of side 7 centimeter, if I place a hemisphere that just fits over it, so we can say it's the diameter, right? The side here, the side of the cube that is is should be equal to the diameter. And I can say therefore the diameter will also be 7 centimeter. As you can see, they are coinciding. And these two lines are coinciding. Okay, we got it. And then we have to find out its surface area. Right. To find out the surface area, there's few things that we need to visualize, and that's an important skill here. Let's say if I set it aside. Now, what we can find out that here the four faces of this cube, right? This is the four faces, one this, one, second, third, right? And the front and the back. These are not covered and they are not disturbed. So we can say, let's say if I find out the total surface area, I'll say that its faces are undisturbed, except for the top one, all five faces are exposed. So it should be 5L square. Now further we can see that a new surface area being added because of this was not earlier present, so this has to be added on it. So if I add this surface area, which is nothing but the area of a curved surface area of a hemisphere, which is 2 pi r square. But what is important to consider and visualize here that if I look this same solid from above, like I'm going to look this solid or visualize it as you look it from the above, how does it appear like? It should appear, okay. Yeah, it should appear like this, right? Because when you place any hemisphere over a square, these areas remains uncovered, right? These corner areas remains uncovered. That means we have few more areas to be painted or yeah, find out is what and how to get these areas. It should be what these areas will be what the area of a square that is L square minus this being the area of a circle that is pi r square. Okay, now if I simplify these two, I can say further without placing the value. First, I can see that 5L square plus L square is what? 6L square. And this is 2 pi r square minus pi r square. That is equal to pi r square. So now rest is just placing the value. What is L here? L, as I can see, L is 7. L is 7. So it is 7 into 7 plus pi, which is 22 over 7 multiplied by r. R is what? Half the diameter and diameter is 7. So it should be 7 over 2. So 7 over 2 into 7 over 2. Now we can reduce. This is 1 time. This is 11 time. For further calculation, what we can see, this is 6 multiplied by 49. So I should get 49 into 6 as, I can take common, but that's okay. I can do it. This is better. This is coming as 294 and plus this is 77 over 2. So this is finally 294 plus 77 over 2 is 38.5. So if I add 38.5 on it, we should get 332.5 centimeter square. So we can say that the required surface area is this. There's a decimal over here. In the next question, it says a hemispherical depression is cut out from one face of a cubical block such that the diameter L of the hemisphere is equal to the edge of the cube, and we have to determine the area of the remaining solid. So let's say if I make a cube first, and from this cube, we are going to cut one hemispherical depression. So I'm going to cut one hemispherical depression. The depression is cut like this. That's what. Now, if I remove this hemispherical depression, right? So that means this, after cutting, it is removed, right? So you can see that a figure something like this will be obtained. So what else we know here from, that is the L, that is the diameter, right? This is the diameter of the hemisphere, which is given as L is L, right? The diameter here, that is D I'm using, is L here. So I can say L is equal to 2R. That's another information we got. We have to find out so basically a hemisphere is, from the cube, a hemisphere is scooped out of it, just like as you scoop out an ice cream from a cube. So the new area is exposed here, and the area of this sphere is removed. So let's put it aside and discuss the working of this question. So what we can observe that here the 5 faces, that is of the cube, these 5 faces are what? The front, the back, and the 2 side faces and the bottom remains undisturbed. So we can say in this case, what we have to determine is the new surface area. So we'll say that the total surface area after scooping out, we can clearly see that here 5 faces, 1, 2, 3, front and back, remains intact. So this is 5L square. Now a new surface is being added, and that is this new addition of surface area. That means this one is that of a sphere, hemisphere, and which is equal to 2 pi r square, the curved surface area. Now, what we are not considering here is something that we are missing, is that from a top surface, if you visualize the top surface, what you can observe that even after removing this, we are left with some areas that these corners area will remain still be there. When you scoop out an ice cream from a cube, you must have observed that we don't get a perfect square, we get a sphere, and these corners are still there. So we have to find this area also, and this area is going to be what? The area of a square, that is L square, minus area of a circle. Now, if you simplify, this is 5L square plus L square should give you 6L square. And similarly, 2 pi r square minus pi r square should give you pi r square. Now, since r is not given, we are going to get the answer in terms of L only. L as is a variable introduced in the question. So this is pi, and I can write r as what? L over 2, right? From here, I can write r as L over 2, and we have a square. So this comes out to be 6L square plus pi times L square over 4. I can take L square as common, so we'll get 6 plus pi over 4. So we can leave the answer here only, or we may do one more step of simplification. That is this, if I take LCM, it's 24 over 24 plus pi over 4. And this much centimeter, there is a unit over here. I can see there is a unit, right? So let me still go through it. No unit is given, so we'll write down this much on a square unit. Square unit. This would be the answer in this case. In this question, it says a medicine capsule is in the shape of a cylinder with 2 hemispherical ends stuck to the 2 ends, right? So let's say if I show you the figure here, the diagram is given. And if I say, if I make one sphere at this end, sphere on this end is going to be what? Like this. All right. It's fine. It looks like a sphere. Fine. And the other sphere I'm going to make over here. That's okay. Now, there is one sphere. If I shed it, this is one sphere over here and the other sphere and this at this end. And I can see the diameter of the sphere is given as 55 mm. And we have the entire length of the capsule as 44 mm, right? The entire length of the capsule is 14 mm, right? Not 44. And the diameter is of the capsule is 5 mm. So let's figure out what we know the radius. Radius, I can say it's 5 by 2, or you take radius as 2.5. Now check here, if I talk about the height of the capsule, which is, see, this entire thing is given as how much? This from here till here, it is given as 14 mm. And if I trim 2.5 from this and 2.5 from this, we should get the height of this cylindrical portion. So height of the cylindrical portion will come as, let's say, if I do calculation, the height of this cylindrical portion will come as from 14. If I subtract the sum of two radius, so h comes out to be 14 minus 5, that is equal to 9 mm. This is mm. We got the height. Now we have to find the total surface area, which is very clear. That is the total surface area should be the curved surface area, as only curved surface area is exposed, of cylinder plus the curved surface area of hemisphere. Now, what is the curved surface area of cylinder? We have the formula, that is 2 pi RH, and the curved surface area. Now, you see there are two curved surface area, right? We have two hemisphere. So that's why I multiplied 2 here, 2 times the curved surface area of hemisphere, which is 2 pi r square. Now check what is the what things we have common, right? We have 2 pi r. As you can see, 2 pi r can be taken out common from here. So if I take out 2 pi r as common, what we are left inside, we are left here h, and there is a 2 and 1 r is still there. Now we can start placing the value. The 2 into pi is not mentioned, so 22 upon 7 radius, I'm taking 5 by 2. And the height, which we calculated as 9 plus 2 times r. So 2 times of this is what? 5 only, right? This multiplied by 2 is 5. Now for further calculation, I can see here that 2 and 2 get cancelled. So 22 into 5 is how much? That's 110. And this is 9 plus 5. Okay. Uh, 9 plus 5 is 14. All right. There is 7 also. I missed it. This is 7. So I can reduce this 7 as well by 2 times. So it will come as 220, and it's millimeter square, right? So I'll say this will be the answer for this question. In the next question, he says a tent is in the shape of a cylinder surmounted by a conical top. So what we can do is, let's say first make the figure. First, I'm going to make a cylinder over here and then putting a conical top over it. So big, right? All right. Now here the base is, as you can see, the base over here is, it is a circular base, and so is the bottom of the tent. It should be like this. Now, what other information we have? That the diameter, the height and the diameter. So height and the diameter of the, if I read it, it says if the height and the diameter are 2.1 and 4, that means height is 2.1, that is for cylindrical part, right? For the cylindrical part. So height here, that is h is 2.1 meter, and the diameter, I can say radius is 2 meter. So it should be same as you can see over here also, it should be 2 meter only. Radius as 2 meter. And further it says the slant height, which is slant height is what this is, the slant height. This is the slant height of the cone, and this is given as how much? This part is given as L, right? L is 2.8 meter. Now, if I read further, it says find the area of the canvas used for making the tent. Let's do the first part. I'm finding the area to be used. Let's place this aside. So as I can see that the required area or the total surface area of the material used should be what? The curved surface area of the conical portion plus the curved surface area of cylinder. And we should not include the base. As you know that by default also we do not use the base. We don't put the material for canvas in the base. And this is what already mentioned here, that the base is not covered by this canvas. So the area of the canvas is this. Now I can see that the formula for finding the curved surface area is what? 2 pi RH, and for cone it is pi RL. So I can see what is common here. I can take 2 pi, right? From you here you can see we can take pi r, not 2 pi r as common. We have this pi r as common here. So I can take pi r as common. So if I do so, so taking pi r as common, what we get inside here as 2h plus L. Now we can now place the value here, pi which is replaced by 22 upon 7, radius is 2, bracket 2 times height, and the height is 2.1 plus the slant height which is 2.8. Now this is 44 over 7. This is how much? 4.2, right? This is 4.2 plus 2.8 is 7, right? That what we did here. Uh, this is 4.2 plus 2.8 should give you 7. So this 7 and 7 get cancelled here. So therefore we get this as 44, and the unit is meter. So 44 meters square. That's the answer for the first part here. Now, what we else we have to find out, also find the cost of the canvas, and the rate is given rupees 500 per meter square. So for 1 meter square, it is 500. So the total cost will be what? Total cost should be what? For 1 meter, it's for 1 meter square, it's 500. So 44 meters square, it is rupees 44 into 500. So we know that 44 into 5 is 220, so it should be 22000. So this is the cost incurred for the whole canvas. And the next question, it says from a cylindrical solid cylinder whose height is 2.4 centimeter and diameter as 1.5 centimeter, a conical cavity of the same height and same diameter is hollowed out. So let's say if I try making the diagram first, let's say this is the cylinder. And from this cylinder, a cone is cut out. Let's say if I take out a cone, cutting out a cone from here. That's okay. Now the base of the cylinder, as you know, it is the base is circular, right? So we had a circular base over here, right? And a circular base at the top. Now check here, since we are cutting it, right? We are cutting it. So what will happen here, if we cut this, if I remove it, scoop it out, it's going to be happen that this portion, this portion will be removed, right? This portion, the upper part of that circle will be removed, and I can see a new area will be added because of this cone. A new area will be exposed which was not earlier present, right? So this new area will be exposed here. Now let's say we have to find out the surface area of the required resulting figure. So what we can see, let's the required surface area if I use, I can see that the curved surface area of that cylinder is undisturbed, right? The side faces, plus there is no disturbance in the base. So I can say the base area, which is area of a circle, pi r square, is same as it is. This is removed, so I'm not including the upper upper base. But since a new area is being added, so I can say that it is equal. The new area which is exposed, which was not earlier exposed, is curved surface area of cylinder, that cone, that is pi r l, right? This one here, these were included. Now, if I look into the dimension, first of all, the height of this is given as, so we know height as, this would be the height of both the figure as is 2.4 centimeter. And the diameter, that's the radius, will diameter is 1.4, so the radius will be 0.7. Now check here, what are the things we can take out common here? I can see pi r is common. This pi r is common. So let's me take out pi r common. So if I take pi r as common, what we are left to calculate is 2 times h plus 1 r from here and L from here. So we know the value of h and r, but we don't know L. So we have to find L, and we know the relation here, that is L square is equal to r square plus h square. That's L is the slant height, radius, which is 0.7 square. I can, and height, which is 2.4 whole square. So L square is what? 0.49, and h is 576. So 5.76. So L square comes out to be, L square comes out to be 6.25. So which is, its under root will be what? 2.5 centimeter. Yeah, it's centimeter. So now I can replace this L. So let's say if I place these values here, pi, which is 22 upon 7, radius is 0.7. I'm writing 7 over 2. 2 times h, and height is 2.4. Yes, it was. Height is 2.4 plus r. Okay, here I'm taking radius as 0.7 plus L, we calculated as 2.5. Okay, what things getting cancelled here? This is 7 and 7 get cancelled. This is 1 times, 2 times will get 11 here. This is how much? 248, right? And 48, we have to add 7 on it. So it's 55. 5.5, 5.5 plus 2.5, right? So it's 5.5 plus 2.5 should give you how much? 8. So is it 8? 4.8. 4.8 plus 0.7. That's correct. It's 5.5. 5.5 plus 2.5 should give you 8. Yeah, that's 8 only. It comes out to be 88 centimeter square. All right, so we have got, now let's place the values, right? So what we have pi as 22 upon 7, radius is 0.7. I can take 7 over 10, right? To reduce it, and 2 times h, and height is how much? 2.4. So it's 2.4 plus the radius, which is 0.5, 0.7, sorry, and the slant height, which we calculated as 2.5. So here I can see that 7 and 7 get cancelled, and let it be 22 by 10 only. We'll see later. This is how much? 4.8, 5.5, 5.5 plus 2.56, 7, 8. So that comes out to be how much? This is 16, 17, 7, 6, 8 to the 16, carrying on 7, 6 to 17, 18. That's right, over 10. So we 17.6 centimeter square. But then I can see we have to find to the nearest centimeter square on rounding off. On rounding off, we are getting how much? 18 centimeter square. So the final answer will be 18 centimeter square. In the next question, it says there's a wooden article, and that is made by scooping out a hemisphere from each end of the cylinder, as you can see in the figure. If the height of the cylindrical portion is 10 and the base radius is 3.5, we have to find the total surface area of the article. So what we can see that we know the height here. The height of the cylindrical portion is 10. That's from here to here. And the base radius, this is the radius, I can say as 3.5, or I can take even 7 over 2, or 7 over 2. Now what we have to find out is the total surface area. So the total surface area will be what? The curved surface area of cylinder plus the curved surface area of two hemisphere, right? Two hemisphere. The curved surface area of cylinder is what? 2 pi RH. And since we have two hemispheres, so I'll multiply 2 with the formula of hemisphere, and formula of hemisphere is what? 2 pi r square, right? Right, that's clear. Now we will take out common. I can see that I can take 2 pi r as common. So if I take 2 pi r as common, I'm taking out 2 pi r as common. So what we'll get? 2 pi r outside, and the height is h, and this is 2, and 1 r is left here, right? 2 r. Rest we just need to place the value. Pi as 22 upon 7. Radius I'm taking 7 over 2. Height is given as 10 plus 2 times r. 2 times of the radius is, or let's do it 2 times the radius. Now we can reduce it. This get cancelled. Here 7 get cancelled. 2 get cancelled. We are getting 22, and this is 17. So finally it is 17 into 22. That's 374 centimeter square.